Okay, hello there. Welcome back. I think I did mention 10 minutes, but we made it a little more quick to accommodate all the sessions on time out here. So here we have another interesting fireside discussion, which with Vinayak again. Welcome back, Vinayak. And then we have Nimesh, we have Rangarajan. Over to you, Vinayak. All yours. You can introduce and take over.
Sure. The way we thought we'll run this session is I'll give a short introduction about the topic, and then we'll have introductions, and then maybe we'll go over some of the questions that are relevant in the real-time media space. We'll cover business use cases. We'll cover a little bit of technology as well, and we'll look at the challenges and how it has changed over the years. We'll look at trends as well. So a brief introduction to the topic. I think really real-time data is relevant now than ever before. I mean, the cost per GB storage cost per GB has been falling over the years. And with the advent of machine-to-machine communications, it has become more and more easy to collect data and process it, right? And this has happened across various dimensions, whether it is analytics, business intelligence, streaming analytics, real-time feedback systems, anomaly detections, or any kind of AI/ML inferencing. The other trend that is working in this favor is a drop in the cost of computation and also the miniaturization of hardware from IoT devices in the field, whether it is farming, whether it is industrial kind of setup, whether it's home network, or even like the smartphones in our pocket. Much of this telemetry can be collected and analyzed at a very fine-grained level. The third factor that is driving this is the ubiquitous network, right? So we have 3 and 4G in our phones everywhere, and even the backhaul networks are actually connected via these mobile networks. And there's Wi-Fi at the office or the home. So connectivity is pretty much constant, and the networks have also become extremely reliable. So all three factors are actually driving changes in the way how real-time data is consumed and analyzed across different kinds of industries, whether it's finance, healthcare, retail, logistics, and even agriculture. So let us start with the introductions of the background of each of the panelists. So I'll go about myself first. So currently, I work as CTO in residence at Microsoft for Startups, which is a team inside Microsoft that caters to startups and helps them scale. I have over 18 years of experience across multiple products, have built multiple products across different domains such as IoT, large-scale networks, large-scale data, in a variety of roles as individual contributors and senior technological roles. And previously, the companies that I work for are like Akamai. I was an early employee in Mobi and built a data systems there. And also, I was last before I joined Microsoft, I was a CTO at Zoomka. Over to you, Nimesh and Ranga. Maybe a quick introductions before we kind of jump into the questions.
Ranga? Sure, yeah. Thanks, Vinayak. My name is Ranga. I'm the founder CEO of the data team. At the data team, we are building a large-scale enterprise-grade customer data platform. Prior to this, I was actually in an organization called as Teradata, so a principal data scientist. So I've been in the data science space for close to like 14 years now, ever since I started my career. Thanks.
Hello everyone, my name is Nimesh Mehta. I'm the founder of Rockmetric. Rockmetric is a cognitive data analytics platform. It helps business users to basically access their data, large data sets without having to learn SQL. My personal background has been I've been a management consultant before. I come from a business background, and I've been working on products for the past 6 to 7 years, and been working on Rockmetric for the past 4.5, 5 years.
Cool, great, Nimesh and Ranga. So let's start off with the business side of things, right? Like, so what are the some of the use cases that you're seeing where real time data fits in really well, whether it is finance, logistics, retail, e-commerce, customer service. Can we talk maybe a little bit about what you've seen in the field?
Right. So so like we were discussing the backside about Lambda architecture, right? So there are like two separate nodes, right? One is basically where you have machine to machine operations working, where you have streaming data coming in, and we'll work on fraud analytics and others where human beings are not involved. And the second stream is basically where the batch process happens, and that goes to business users, where the information goes to the business user notification, where they can explore, do root cause analysis, and then start taking action automatically. So our observation has been from the first part, like we discussed, high frequency trading, recommendation systems, having alerts for fraud. All this takes care. But the second one is something where not too much work is happening, where businesses are still working on a T minus one, or even sometimes every 15 days or a month. Even very large organizations are not moved to giving users even near real time access to their data, and this includes basically having field force having access to information like, is there any big account which has removed money from the bank, and do they need to call the customer? Is there a particular agent where the sales have suddenly start dropping it this particular day, or any big money has flown in so that you can just take action. So people to people interaction basically is something that those workflows are not very well explored in the market yet.
Ranga, do you want to add into that?
Sure. Yeah. Yeah. I guess one thing to clarify is that real time has been around for a long time now, right? If you go back in the days where the world of banking was automated using mainframes, and beyond that, transaction processing systems, and after that, we're talking about core banking software coming into play. Each of these had their own contributions towards processing transactions and payments in real time. So, as such, as a topic, it's been around for a while. But I would say that where things are becoming very interesting nowadays has been the confluence of the data processing capability itself, the general purpose nature of that capability, and marrying that with the explosion in the volume of data that's being generated, to your point, Vinayak. So here, variety of different types of use cases, like Nimesh was pointing out, where real time really makes sense is when machines communicate with each other. Because if it's meant for human consumption, it automatically stops becoming real time. Right? It becomes more batch, because humans have fundamentally latencies of processing. So with machine to machine communication is present pretty much in every industry, like telecom, banking, oil and gas, uh, logistics. All of these are traditional industries which have always been around. And then, of course, you have the new age industries which have emerged digitally, like the e-commerce companies, advertising technologies, ad tech companies, martech companies, etc. So there are, I would say, use cases across the space. Uh, in some industries, it's core, fundamental to the operations itself, like banking is a good example. In other industries, it serves a very useful way of adding to the top line. Like, for instance, personalization. Like, nobody would think about Google as just a search engine company anymore. People think of Google as a real-time ad company, right? That level of personalization has been proven now to generate tremendous amount of top line growth, right? So it goes across the space is what I would say.
It's interesting, right? Like, we talked about finance, we talked about logistics. I think whether it is like assigning riders, to pick up and you get food for food delivery to high frequency systems. But one of the most interesting use cases I've seen in cases is where like you are in a greenhouse, or you're doing hydroponics, right? And you can actually have what is known as vertical farms, and you see these vertical farms actually you see these vertical farms actually have sensors, whether they're soil sensors, temperature sensors, and they actually get data and then keep on constantly adjusting the atmosphere, so that the yield and the productivity is optimal. And parallelly, this data is also collected. So that is one of the use cases that I've seen is fairly interesting, and which is not kind of thought about in the mainstream, because the finance and the other ones we actually know about that. And as Nimish said, when there is human in the loop, there are near real time systems also. Just to give another good example is, like, for example, um, at Zoomcar, right? Whenever you, for example, sign up and then you upload documents, that again, there's a human in the loop, but there's also some amount of I would say parsing and image recognition that happens of any ID, and then the human says, okay, does this look okay or not? If it falls between a certain confidence layer, right? So while it is not like real time in the sense where decisions are made in seconds or microseconds or milliseconds, but still, I mean, the SLA is like typically like 5 or 7 minutes. So that's also very interesting use case that is there. So yeah, we talked a little bit about the use cases, but now let's talk a little bit. Let's talk a little bit about the technology. What are the kind of tools that are used to get this analysis at all layers of the stack, right? You talked about how storage has become cheap. So storage, processing, whether it is enrichment or ML or machine learning or AI, or even if it is like some amount of business intelligence or trend spotting, and then finally database. Um, Maybe we'll start with you, Nimesh. Like, what have you seen in the field? What are the tools that you use?
So before using the tool, I'll just say from an approach perspective, having real-time machine-to-machine workflows, building systems, and building systems for basically analytical workloads and large-scale batch processing are very very different. So most of the customers that we interact with, uh, that is a huge effort to make them understand. When you're building real-time systems, the approach, the skills, everything is very very different. So just wanted to highlight that first. Our experience has been that in terms of machine use cases, right? Most customers have been talking about fraud. Having systems where you have streaming data or events data coming in, and either we give recommendation or we set up a fraud alert to another system as an event after that, right? So building event-driven system is like the most important thing that people are struggling with. And the second aspect is then how do you get that data into storage for batch processing after that. There's a lot of trouble. Most people have taken up external tools or systems to do the first task, but then managing the data to train their model to improve their alert engines is something where they start struggling once again. I think that's where people like Ranga can really add value to them. But that's something that people underestimate how much effort it takes to build this out.
Cool, Ranga.
Yeah.
You want to add to that in what tools you have seen in the field?
Sure, yeah. So again, back in the days, it used to be called as complex event processing, right? CEP, and there were legacy systems which were extremely closed source, very hard for people to contribute or understand what was happening inside the black box. But over time, what's happened is that open source has really caught on to the extent that now there is open source innovation happening at the hardware level itself. And by that, I mean even things like Raspberry Pis, right, which are deployed at the edge in an extremely decentralized fashion. And these edge devices are collecting data always, like real-time data about sensors and stuff like that. So right from that point on, there is innovation that's happening. And that's also contributing to this real-time wave. And then the data comes through invariably some kind of a cloud system. So when it comes to the cloud system, it becomes a case of how do you know that this is the data that you're supposed to be getting. So there are some security mechanisms that need to be in place, like for instance having a gateway systems which govern what the devices are. So because that becomes an important factor. So there are tools for that as well based on what your poison of choice is. And then once it gets past the cloud, once you get inside the mechanisms of what do you do with this data, there are so many open source technologies available now which do the same thing that CEP used to do really well. Like folks like Spark, Flink, variety of different variants of those as well. Like some of them are like platform as a service options in cloud. Some of them are just open source virtual machines that you can just get it from the marketplace. And then you invariably need some kind of a database to store things and process it. So the database could be like extremely real-time NoSQL systems, or could be message buses like Kafka. So variety of options there. And then eventually there are also capabilities which are being built in visualization providers, right? And these are tools which allow you to visualize data very, very quickly. Like for instance, Kibana in the Elasticsearch
Right.
stack. Likewise, other kinds of visualization tools as well. So entire gamut is available. Um, Even in the machine learning space, I would say that there's a lot of research that's going into taking algorithms which have been trained in a batch way and making them available for a real-time pipeline to use in a real-time scoring setting. So even those are available in the form of various technologies within the Spark ecosystem, as an example, within the Python ecosystem as well.
But I one thing that customers also need to take care is like from a business perspective, the cost of managing so much data is very very large. So planning such that when the streaming data is flowing in, you have your workflows automated, and then how quickly can you put it into an aggregated format and then use it for consumption or training your models later. That needs to be done really well. Otherwise, having very large in-memory systems to store all this data and make it work real time can be a very costly proposition.
Yeah, right. Again, like, even I have seen a variety, right? Like, we've seen like in-memory databases, we've seen processing systems. Backstage, me and Ranga were talking about real-time, systems based on geography information, right? As I said, like smartphones give you that data today, right? We can say it's surveillance technology. We can say it's something that helps find, right, like when you, for example, do food delivery, you can also see in real time where the guy is actually, and before you maybe go down to the the base of your apartment and pick up in this time. So and all of this is like running in real time. But I mean, the other thing that Nimesh says is like the cost, right? So many times I've seen in my own business setup where people actually ask for real time setup, but when I ask them, if I give you this data, what will you do? Sometimes the answers are not very obvious, and that is the other aspect that we have to see, right? Like there's a cost both in terms of building the technology and running it operationally, right?
Right.
So I mean, if you ask anybody, they would want, yeah, I want data real time, but what is the cost of actually running that, both in terms of running the infra, but also in terms of people's attention to it.
Right.
So the use case has to be very.
That's where the tragedy is, no, Vinayak. So most people want have KPIs or KRS of buying tools or implementing tools or not solving problems. So if as partners or vendors we bring down their cost to solve their problem faster and cheaper, the partner will end up getting less money and not more. So incentives are only completely misaligned for the industry.
Yes, yeah. So one more use case I wanted to address is like some of the hosted solutions that we have seen are very interesting. Like the machine learning has become so advanced that even people have trained models, and they are actually running on commodity hardware. Like for example, have you seen cameras that are hooked up to chips, and the whole setup costs maybe like about 15 to $20. Like, and it can basically like, for example, you go to the airport and it allows you access to go into the airport, and people have optimized the CNNs that are there to actually work even in an offline mode, and that is something that is very interesting, right? So because the network is actually available, sometimes we are seeing the split between what is there in the IoT world, and also some of this data is also pushed to the cloud whenever it is available as well. So there is this kind of duality. You talked about client server computing, when it has now come back in the form of cloud as well. So you see that split as well in real time systems as well. Moving on to
Yes, Vinayak, sorry to interrupt. It was very conservative, but I have to just put up a little pause out here. I think we're running out of time. So can we quickly grab some questions and then pause it off? So 30 seconds for 2 questions, maybe.
Sure.
So in the question section, you have one where you can pick up, and then we can.
Yeah, so Ranga or Ramesh, you want to pick this up? This is on quality of
Ranga's
data.
expertise, huh?
So, sorry, I couldn't see the question. What's the question
Yeah,
again?
so I'll read out a question for you. The bottom line for getting quality data is creating a culture where everyone is responsible for accurate data. How is India placed currently in this area, and what is AI's role in enabling this?
Okay. Okay. So quality, yeah, of course, quality is going to be a consideration across any use case that you take, be it real time or batch. Frankly speaking, I think AI can play a very critical role in ensuring that data quality is ensured at the point of collection itself. Like the best example is, for instance, if you have a human that's collecting data, as an example, taking photographs of a car involved in an accident. Let's say you're an insurance company and you want to collect the data in order for you to assess what the damage is. Then at the point of image taking itself with your smartphone, an AI can actually advise you to say that this image is not going to be of good enough quality for a CNN to be able to do its thing. So that advice at the real time allows the feedback to go to the human to be able to take a better quality image right there, right? Whereas in a machine-to-machine setting, it's much harder for AI to play a role to ensure better quality. But then again, it's machine-to-machine, so the machine is collecting whatever is being fed to it. So as long as the sensor that the machine is using to collect the data is good enough, that should be fair enough from a quality perspective. That's the short answer. Of course, there are models that you can build in place like forecasting and stuff like that to ensure that outliers are managed based on the trend that you're anticipating. I don't think India's in a way specially placed here compared to other geographies. Vinayak, if you want to clarify what's the situation with India compared to others, I'm not sure there is anything there.
Yeah, so I'll talk about a very interesting use case, right? I mean, Ranga, you talked about sensors, right? So I was talking to somebody who was working in Microsoft Research, and what they're doing research is uh, uh, the data is only, I mean, the inference is only as good as the data, right? But who will, in some sense, watch the watchmen, right? The sensors are the watchmen, but how do we know that the sensors are working properly? And especially in a farm kind of scenario, there were cases where the sensors were not giving the right data. So they used to look at the electronic characteristics of the device when it actually shut down. And what we saw was when they look at the electronic characteristics and collect for data for a few microseconds more, right? The curves that they plot over a period of time, they can distinguish the good sensors from the bad sensors. And they do this in real time, right? Like whenever the reading is taken and sensor switches off, or whenever the power cycle happen, they calibrate the response and then figure out based on the electrical response of the sensor how it is performing. So basically, then what happens is at the point of getting into the cloud, also that data is actually thrown out, right? If it does not conform, right? So for example, there was a sensor that looked at the soil data, right? And it had like these two prongs. But what happens when a tractor runs is one of the prongs broke. So it was giving a reading, but it was not accurate. So if you just looked at normal kind of real-time data rules, you would see that okay, it is giving a reading and it is within the range, but that was not accurate data, right? And then you had to look at the electronic characteristics. So there is obviously a data culture and human part to it, but when it comes to real time and machine to machine communications like Nimesh and Ranga talked about, I think there are some creative ways of looking at maybe the electronic characteristics of the devices, looking at anomaly detection systems, and look at past trends to actually gate and stop the data from coming into the system so that inference can be stronger.
Okay, sure then. Thank you so much. So I think we are again running tight of the schedule. So I think so. Any more questions, would be answered. I think the team is going to address it to individual speakers out here, and then they are going to write to you. So we are going to make sure that they are going to write to you. Okay, thank you so much, Vinayak, Nimesh, and then Rangarajan. Nimesh, do you want to put up a closing sum, for 10 seconds?
So what I would like to say is, like I generally keep talking about what the business user will get here, right? So one aspect was getting the machine to machine and other things, and that's one thing. But from an end user perspective, also there are a lot of small things that need to be done for them to just make sure that the master data is clean. Your master data management itself can, have a lot of innovation in terms of helping them identify where the data errors are happening, cleaning the data up, allowing master data refreshes. A lot of basic stuff that can be done where business users can clean up data post facto, and that will feed into your model which is getting trained. Having bad master data and then having a big analytics team setting up, the business user is changing their field hierarchies every 3 months, and if the data doesn't go into the model, there's no point. So that interaction between business users who are actually generating the data and the teams which build the model and finally machine to machine where it gets deployed, that entire cycle needs to be completed.
Sure. Thank you so much, Nimesh. Thank you everyone out here. Thank you, audience.
Thank you,
and then we'll move to the next session without much break. Just in 1 or 2 minutes, 1 minute, we'll be back. Thank you so much.
Thanks, Nimesh.